Okay, so I think we can start. Hello everyone, welcome to the fourth Flutter Wrocław Meetup. Today we are your hosts, Jan Kamiński and Katarzyna Ciężczyk. We are here at Concordia Design Wrocław, but we are also on live streaming. So please let us know if you can see and hear us. We have three exciting presentations lined up for today from three fantastic speakers. But however, before we invite them to the stage, Jan will share a few information about event organizer.
Hi all, I just like to remind you that it's our fourth meetup and that's the first event that is held in English. And by the way, we broadcast it online, so seriously folks, please let us know in the comments that you hear us. Of course, we have to tell you something about the organizers. One is Applover, which is a digital consultancy and software development company. As you can guess, one of the technical specialization is Flutter, but our domain specialization is health tech. We work for different domains like fintech, media, and entertainment, but health tech is something that drives us mainly. We were recognized as one of the fastest growing companies in our region 2 times. But as I mentioned, Flutter is important, and what we love to do, we love sharing knowledge. You can download our Flutter handbook, where we share some insights on how startups can take advantage of the technology of Flutter. B, it's essentially a guide through the trends in building applications in Flutter, so pros, cons, and obviously the costs, and most importantly, technical prescriptions from our Flutter experts. So, share, comment, like it, download, and share the feedback with us. We will really appreciate that. And the second co-organizer, Google Developer Groups, GDG, is a developer community where you can meet in person, which is important post-COVID, right? Or online, that is focused on Google technologies. GDG are inclusive environments where everyone and anyone interested in tech, from beginner developers to experienced professionals, are all welcome to join. And there are 7 reasons to become a GDG organizer and join the community. A, they organize amazing events. B, you as a developer can gain new skills. You can learn about interesting technologies, expand your network, and most importantly, make some friends, right? Become a point of reference of your local community and become a part of the global family. And of course, we all do it for the swag, as they say. So, there are also 2 announcements. The first one is, GDG is also holding 2 events in Wrocław. One, Google I/O Extended, that will be held in August in Wrocław. And the second one, Network Speed Dating, that will be taking place in June. Check it out on Facebook and on their social media. And by the way, for you who with us today and for our online viewers, we will, for active participants, obviously, that will ask most interesting questions, Applover has prepared surprise prizes, some rewards, as we might call it. So, be active, and GDG Wrocław has JetBrains licenses for you, for the most active commentators, in a sense. All right, so we will probably begin in a minute. Are you excited, or not really? Ooh. Nice. We'll get that vibe. Yeah, perfect. Okay, so the first presenter is Szymon Mazanik, who will share some insights on modular Flutter applications, so splitting your project into packages. Szymon, who's there, is our Flutter lead at Applover with over 6 years of experience, and he started as an Android developer, but quickly discovered the possibilities of the Flutter technology. Followed, by the way, he's there from the early beta stages, right? From the early phase, I would say from the very beginning. And he began specializing in Flutter, so thanks to this, he can now easily build beautiful and functional applications for Android and iOS. He shares his knowledge on the blog, by the way, and you have to check his LinkedIn because he does it there as well. So, without any further ado, Szymon, the stage is yours. Thank you.
Thank you. All right, thank you for that great announcement. Thank you guys for coming. So as you already know who I am, we will just jump straight into it. Should you split your project into packages? Before I answer that question, I want to answer what do I actually mean by modular code base. So essentially outside of Flutter, like in general scope, we have monolithic applications and modular applications. This is something that our colleagues on backend development have been doing for some time already. They split their project into microservices, and they set up different boundaries for these microservices. For example, it can be a completely different programming language, or it can be a completely different framework that we created the microservice in. However, in our case, it usually will be just Flutter packages or Dart packages. So this is what I understand by modular code base. It's when you divide the project into smaller projects and you don't have one big project. And so before we jump into the modularization itself, let's try to talk about the packages first. So can someone tell me, is this a valid Dart dependency? This is there are two files here. It's pubspec.yaml and it's a Dart file. And these are the contents of these files. So the question is this a valid Dart dependency? Anyone? Okay, so I'm going to answer yes, it is, because this can be imported into a different project. It can be used as a package in a different project, and also you can add new packages to this project and use it in scope of this project. So this is as little as you need, just two files. And how we usually do that, we already know. We just give the dependencies and the name of the package that we have. We don't even have to set up a version of the package. We can just leave it like that, and it should work. Flutter will figure it out what version of the package it should use. But what's actually happening under the hood when we are executing Dart pub get? Because if you are working on a Dart project, you don't have to execute the Flutter pub-get that we probably use in our everyday workflow. We can just do a Dart pub-get. So the first thing that gets created is a pub cache directory. And this directory is actually outside of your project, of your repository. You see, because whenever you are using a package from a pub.dev, this package needs to be downloaded into your computer, and this is how it's being used. So in case of my computer, which is a Mac, for example, this directory will be in the user of the user that I'm being logged into. And there you will find all of the Flutter and Dart packages that you use across your different projects that you have ever installed on your computer. The second thing that's getting generated is the pubspec.log. So do you remember how I told you that you don't have to specify the version of the package that you are using? Well, Flutter has to figure it out somehow and save it somewhere. So this is the content of this file, and one of the things that you can find here is the actual version. So if you are wondering what version of the package is being used in my project, if I don't set it to anything, you can find it in this file, and also you can find some other interesting information about package here. And the third thing that, and I forgot about one thing. Can someone tell me, should we add this to our Git repository or not? Okay, so the answer is not that simple, unfortunately. So for our projects that are in the end being compiled to applications in our private projects, I would say we should add this to the repository. However, if we are working on packages, especially open source packages, we should not add it to our Git repository. And the next thing that is getting generated is the whole directory that you see here, the Dart tool. It's not being checked into your Git repository, and the reason for that is very simple. You see, because in this file you will find where your packages are actually the path of your packages on your computer. So if you are ever offline and you need to fork a package, you don't really have to do it from a Git or something like that. You can find it on your computer, assuming that you already use it in your project. And this is where you will find it. Like I said, you don't commit that to your Git repository. But this will not really work for us because we talk about modularization. This would mean that we have to get the packages, publish it to pub.dev, and then somehow access that. But if we are creating a project at a company or something like that, we probably don't want to do it. So how do we deal with that? The answer is very simple. We are going to host our own pub.dev. And the way we do it, you see, because pub, like any other software related to Dart and Flutter, is an open source software. So there is the pub code is on a GitHub. You can find the communication between server and client here, and you don't even have to reverse engineer that in any kind of way. The documentation of this encourages you to write your own backend for pub custom repository with packages. For example, here you have the answer from the server, the API that you should have whenever you are doing Flutter pub-get. But fortunately for us, we don't really have to write our own backend code because we have open source alternatives. And this one, for example, is interesting. It's made by ByteDance, so it's the company that created TikTok. And here you can see how people are using this kind of thing. If you are a company based in China, you might want to have your own package repository because you cannot access the official one, right? So this is a tool that you can leverage. And on top of that, if you don't want to deal with it at all, you don't want to provide your own servers, there is also a cloud-based solution. There are many cloud-based solutions, but I want to talk about the JetBrains space because JetBrains was kind enough to give us licenses for this event. So if you want to, if you are active, you can win a license for JetBrains software. And here it is very easy to set up because you just literally can do it from the UI level, and you don't have to do any programming, anything related to that. So here is where the strength of this solution comes into play. Whenever you are working with private package repositories, you would probably want to have this hidden from the outside world, right? So you don't want anyone to access your packages. And you can create the authentication for the pub. The way you do it, you can set up this in your own terminal. You just say Dart pub token add and the host of your package, the package repository, and then you enter the secret token that authenticates the package repository. You can also do this as environmental variable, so this will also work with any kind of CI/CD solution. And how do we actually use our hosted packages? Well, we can add a parameter to our dependency with the URL the Flutter should use to get the package, and also you can set up a version here if you want to. But that would be a little bit annoying to set up for each package, for each dependency. So there is a way to do it globally. And the way you do it is by setting this environmental variable. So the thing here is that you cannot really do it, as far as I know, on the project level. So if you are using a custom package repository in your project, you kind of have to train your people to use this and to not change it, right? But what if we don't want a custom repository, because that's kind of a lot of work, right? We can, of course, access the packages locally, where we just give a path to our package, and you can also do it directly from Git. And what's interesting here, in the Git case, you can even target a certain branch that you want to use, and you have different options for using the advantages of Git. So now that we know how to source our packages, how in a different way we can get it into our project, let's talk about some examples of modular apps. And the most shining example that I found is the eBay Motors application. They created this blog post where they say that it was very important for them to divide the logic and the domain of the application with clear boundaries. And these boundaries for them are separate Dart and Flutter packages. So highly recommended reading that, because it explains a lot of cool stuff about large-scale projects. And another example will be the one that we probably all use or at least heard about, is the Flutter Fire repository, because you see each package related to Firebase is actually a separate Dart project. I think that's not a surprise, but how this is being stored on the Git repository, they have a packages directory where you have all of the packages listed, and there is like and this is not a root of the Git repository, right? So this is another example of how this is being leveraged out there. So that brings me to another topic, which is the strategies for organizing your code base into modules. And like I mentioned about the eBay application, they divided their application per feature. So what that means is that they have a certain feature that they figure out themselves. For example, it can be something like authentication, payments, maybe user profile, and each of these will be a separate Flutter project with clear boundaries where something starts and where something ends. Another approach that we could use is the division per layer. This is a different one. It kind of resembles the topic that we were talking about last time, which was the clean architecture. So here we can see that we have our project divided to different layers, and in that case, the presentation layer most likely would be a Flutter project, while the domain and data packages would be clean Dart projects. And I like this strategy a lot, because it prevents us from making mistakes on architectural level on in compilation time. Because if someone will try to import some classes related directly to Flutter in the domain package, or the other way around, if they try to import, let's say, DIO in our presentation layer, they will be not able to do that, because there is no such dependency in the pubspec.yaml, right? So you can just not import that. It prevents these kind of errors that usually would be caught in code review. This time you can prevent that on a compilation level. And I wanted to, and one more thing about these strategies is that you can also combine these two. So here we have also division between the Dart packages and Flutter packages. But in this case, we can see that we are using, for example, local database in all of our features across the app, but authentication can be only used on one feature, one package, and this will divide our code base into even smaller pieces if that's something that we want to. And how would the file structure look like in this case? So this is an example taken from the Firebase package, of course. So we have, notice that we have the pubspec.yaml file here as a top-level project, and inside we have packages, and each one of these, the authentication feed, each one of these would be a separate Flutter or Dart project. But on top of that, there is one, usually Flutter project that puts everything together. But I wanted to show you an example of how we actually leverage that at our company to save some time and create working solution. So we had this case that we were doing a food delivery app, and in food delivery app you have the customer app where people order the food, the business app for restaurants, and we had a Flutter web admin panel that was being used only by the employees of the food delivery company. And as we started working on all of these three front ends, we quickly realized that all of them are using similar endpoints, similar data models, or in many cases the same, similar authentication methods because everything was authenticated with Firebase. So we realized that if we are going to approach this with a classic monolithic application style, we would be doing a lot of copy and paste between different projects, right? So instead of that, we decided to use the combined strategy for the modularization. And what we did was we divided this presentation layer for 3 parts, as you can see here, and then each one of these was using a domain package that was handling the whole logic and the stuff that I was just talking about. And how would that file structure look like? So in this case, we don't have the pubspec.yaml outside, like at the root of our repository. Notice that there is only git ignore here to indicate that this is a Git repository, but there is no pubspec.yaml. This is because there is no top-level project Flutter dependency that puts everything together. The admin, the business, and the customer, each one of these is a separate Flutter project that just uses a package. It's in this case, it's domain. And in this case, we can just say that we want to target the local path, and notice that you can target the dependency outside of your Flutter project using the double dot at the beginning. And I think that managing all of these packages might be a little bit difficult, right? Because think about it this way. If you have to execute a build runner or do something like Flutter pub-get in all of the projects, assuming that you have many of them inside, you will find yourself either executing multiple commands for the same command for different projects, or you can create some bash script that will do it for you. And in the age of AI language models, it's not that big of a deal, I guess. You can just say to ChatGPT to generate that for you. But fortunately, we don't have to do that because there is a tool that allows us to manage multiple packages, and the name of the tool is Milos. And I would love to dive deep into this tool. Maybe one day I will do a whole presentation about it. But for now, I'm just going to point the most important information about this thing. So like I already mentioned, executing commands across different packages at the same time, this is very useful if you work with a lot of packages. On top of that, we got automatic versioning and publishing. This will be very useful for you if you work on open source software, right? And then if you are using a lot of packages, you also might want to list the packages and see what is being used under the hood, so you can create somewhat of a dependency graph out of this. So this is a very useful tool. And let's talk about some benefits of this approach. So like I already mentioned, it's for me at least, in some cases, it's easier project management and simplified code base. Because when you have your project divided into smaller packages, from my perspective, it's easier to manage, especially if you work in a big teams, which brings us to another point, which is enhanced team collaboration, because you can set developers to work on a certain parts of the app, and for example, you in companies or corporations that have huge teams, you might have a team that works only on authentication, and then you have a team that works only on payments and checkouts and stuff like that, and then you have a team that works on something else. So you might find it useful when you are working in many teams on one code base. And then, as I mentioned, in case of our food delivery app, it was reusability and reduced redundancy. So we didn't have to copy and paste a lot of code across many different projects. We just had it in one place. We were using this that way. But of course, as any solution, any kind of approach, it has some challenges and downsides. So, for example, one of these is the initial setup complexity, because at the very beginning of your project, you have to make difficult decisions. Do we do division by feature? Do we do division by layer? How do we want to approach that? Then it's kind of hard to test that, because you have to persuade your team to go into this and to start working like that, because only then you can see the benefits of this approach, right? You can't really test it at home. You can try it by yourself, because maybe you will be successful, but it will not show its advantages then, and you might consider it a waste of time. So I think that's a little bit hard to figure out. And then we have module interdependency issues. So if you find yourself in a situation where you need to use a certain data model or something like that in a specific layer, and then it needs to be moved or transported into another layer, you have to figure out a way to do that. Will you do it through some kind of dependency injection solution? By the way, the injectable package has an API called micro packages, and it's a very good dependency injection for this kind of approach that we are having here. So I would recommend that, and but unfortunately, if it comes to the interdependency issues, it will be a daily topic on your daily meetings, whether we should import something in one package or another, especially if you are doing the division by feature. So the last question that I want to ask is, who is this for? And I believe this is for big teams working on a large modular code bases, right? So as I already mentioned, in the corporations or companies where you have teams who have expertise on stuff like I already mentioned, who are expert on a certain topics, and they just want to work in scope of their own thing. This would be very useful for them. If you are working on the project alone, you might want to try that, but I believe that it would be kind of difficult to see the advantages. So that's it from me for today. Thank you, guys. Do we have any questions?
Thank you. And of course you can ask questions. I see the first candidate, but just a quick announcement before. You can also ask the questions online. I have the device here and I will be seeing them. Thanks to our great marketing team. Thank you, guys. So we'll start here, right? I will just give you a mic.
Thanks, Szymon, for great presentation. I have a question regarding pros and cons of keeping the packages that you have in the project on external distribution versus just keeping them on the repository.
Yeah, sure. So in general, you want to keep your packages in a single repository whenever they cannot kind of live without each other, right? And especially if you are using this for a single project. It wouldn't make much sense to set up a custom online repository if you are doing this for just one project. But assuming that you have many different projects and you have some kind of package that you want to use across many different ones. For example, in our company, we are working together with designers, and we have one style of widgets and one kind of of blueprint of widgets that we want to use, and it's communicated with the designers very well. And there we have a package that is hosted on a custom repository that you can always add to a new project whenever you are starting something, or you just want to use this package. So I would say that it largely depends on the project we are working on.
All right. Any other questions? Okay, I see the second candidate. Nice. One sec.
Hi, so did you face the performance issue? I mean the performance of IDE. So in the big projects with a lot of packages and the analyzer of that being heavy to the computer.
Yeah, that's a very good question. I have to admit that in my case, working on the Silicon Apple processors, it doesn't make that much of a difference, because the processor is so fast already that it's hard to spot the difference. So I can't give you like concrete data on this, but if I can talk about my feelings regarding this, I feel like there were no major performance issues using the modular approach.
Okay, I have one question from the audience that's online, from the YouTube stream. So basically, have you set it up with Riverpod? How its DI works for modular projects?
Yeah, sure. So if we are talking about state management, it doesn't really matter if it's Riverpod, block, or anything, right? Because as I showed you the layers of that we can use, you could even do something like if you have this thing, for example, if you have a project big enough, you could have a completely different state management in the sign up, because that would probably might be better for you using Riverpod in sign up, and then maybe user profile has a different needs or different teams works on that. And you can use, for example, block in user profile and provider in feed.
Okay, and there's a follow-up actually. Yeah. So how do you find the setup if you've ever applied it? So let me repeat. Yeah. Actually, how do you find the setup if you've ever applied this?
So how did we find our setup, right?
Yeah,
if that, yeah, okay. So in case of the thing that you see here that I showed, I don't think this is the slide. Yeah, this is the slide. So in case of this application, we just kind of took a risk, because at first, at the very beginning, we started working on this as a 3 separate Flutter projects with 3 separate people working on that actually. But as I mentioned, we quickly realized that we are copying and pasting a lot of the code. So we just made that decision, took the risk. It was our first project that we divided like that, and it paid off.
All right, thanks for that. Any other questions from our online audience or the live audience? I see no hands. Maybe online. Let's give it like 1 minute for the ones that just like to ask something at the very end. Okay. Okay, so thank you for that. Thank you, Szymon, for the presentation. And of course, I know knowledge is exhausting, so we will have 15-minute break where you can enjoy the drinks there, enjoy the food, and then we'll reconnect in 15 minutes. So for the online viewers, hope to see you soon. Thank you.
Thank you.
Okay, so I want to invite to the stage the next speaker, Krzysztof Krasiński-Sroka, who will be talking about introduction to shaders in Flutter. Krzysztof is a Flutter freelancer, developer, international speaker and community organizer from Wrocław. He fell in love with Flutter's speed, capabilities and developer experience since starting with the SDK in October 2018. So, Krzysztof, the stage is yours.
Thank you. All right, let's see the screen. I'll just have it on my laptop and tell you what I see. Great. Yeah, so as mentioned, this is going to be an introduction to shaders in Flutter. Who of you does know what a shader is? One person, great. Two people. Yeah, that's good because it's for people who don't know what shaders are. The two people, well, will be bored maybe. But let's start a little bit about myself. I graduated from University of Wrocław in 2009 as a master in computer science. And since then I've been doing programming in one way or another, or developing software in one way or another. I'm a GDE for Dart and Flutter since 2020. That's when I also co-hosted the Flutter Europe conference in Warsaw. In the last 3 years, I've basically been mostly consulting. I founded Widgeters, which was one of the first consultancies that was dedicated to Flutter development only. And now I'm back to being a regular guy, senior software engineer at Superlist. What are shaders exactly? They are definitely for shading, but shader is a program for graphics manipulation. So that's something that I could tell to my father, and he would understand because he's not a computer person, but he would say, yeah, I understand what you're talking about. That runs on GPU. So shaders are not like your regular Flutter applications, as they run mostly on CPU. Shaders run on GPU. And I'll talk about a little bit what happens on GPU because it's not that straightforward. And this is one of the very simplified models of GPU processing. If you go on the internet and Google about how does the GPU work, you'll find like 50 different images which basically say the same thing as this one, but with different words or in different scope. So the GPU starts with basically 3D modeling. So we send to the GPU some models of vertices, some colors, some textures, and it first starts processing the 3D models through vertex shading and geometry shading. And once it's done with 3D modeling, it rasterizes this to an image that's basically converting the 3D model it got to pixels, the matrix of pixels, and then it does the fragment shading, which is what I'll say about in a moment, and ends up with an image that you see on your screen. And in Flutter, we'll only be handling fragment shading. Right now, there are maybe some plans for the future with Impeller to actually expand this to allow for more processing and involvement in different stages of GPU pipeline. But as of now, fragment shading is what Flutter does. So it actually is executed on a rasterized image. And shader is actually executed for every pixel of a rasterized image. So yeah, how many pixels is on a regular mobile phone? Like, anybody? Quick. I think about 3 million. Like the most popular resolution is 800 by 320. So that would give us 2.5 roughly 2.5 million of pixels, and the fragment shader is a program that runs for every single pixel, actually sometimes more than once for every pixel. And how can it do it? It doesn't run on CPU, because CPU is like this huge pipe. Actually, it's like maybe 8 to 10 pipes called cores on a modern mobile that process lots of data. They have really good latency in processing data, but they do it sequentially most of the time. So if you have like a regular CPU, it's not going to be quick to process about 3 million of pixels at the same time, each frame. That's where GPUs come. So GPUs are architected a little bit differently, and let's say modern GPU on a mobile has about 500 cores that execute for each pixel. So even with the modern CPUs, it's much bigger scale of processing, and most of the time, this is enough, more than enough to process what we have on the mobiles. Actually, on NVIDIA's like modern desktop NVIDIA's, it's 10,000 cores for GPUs, so you can see the scale of the processing, how quickly it can actually do the images. Of course, this comes with restrictions, but these tubes are small. So they don't handle a lot of memory at the same time, they don't handle a lot of process at the same time, they need to execute quite quickly. Another thing Fragment Shader is a program written in a domain-specific language. So we are unfortunately departing from a nice and comfy world of Dart, and we are going to use something different. And there are actually plenty of domain-specific languages for shaders. And every major producer of GPUs and every major company that specializes in graphics has some kind of language that they use. So Microsoft has actually 2 languages for different versions of DirectX. Apple has its own Metal language. There's a separate language for GPU processing for web. Adobe has one, Sony for PlayStation has one. One of the popular ones is NVIDIA's, because lots of people mine also using shaders. And one thing we are going to actually use is GLSL, or actually a small modification of GLSL called Skia Shading Language, or SKSL. When I was doing this presentation about 2 months ago, Impeller wasn't yet enabled, and it changes things slightly, but most of the things that I'm going to talk about are going to be applicable right now to all your apps. And I can answer maybe some Impeller questions later on, but I don't know that much about it yet. So how does a shader look like? And people who like C++ or C will be really satisfied with this, because most of the shading languages are written in C or C++ style. However, there are some modifications. Let's see, this is a very simple program. Most of the shaders are small. Let's say a couple of hundred lines of code for most of the shaders, I guess. And they could do a lot of image processing. I wouldn't recommend actually looking at the shaders examples, because they are written in a style that doesn't think compilers exist. So that, instead of variables color, they would say C %PC, because saving time, I guess, in writing code is important. Let's just go through this code that we have now. So first we have this Pragma version 460 core. This actually specifies the version of GLSL that we are going to use. Then we include some helper functions from Flutter. This is very specific to, of course, Flutter. Outside of Flutter, if you put this in a shader, it will not compile. Then we declare some variables. And here you have here we have two things. So one is the out variable. So it's result variable called frag color. So as you can think of processing on pixels, what we get from processing a pixel is actually a color of a pixel, and this color is going to be written to frag color, and it's going to appear on the screen later on. And you can see frag color is a vec4, that means vector of 4 floating point numbers, I think double precision floating point numbers. In shaders, we basically have double precision floating point numbers, vectors of these numbers, and matrices of these numbers. That's all we have. We don't have really processing of fixed integers or other data types. And this is basically for simplicity as well as to make a GPU really more focused on some data. And here we define actually vectors of three numbers. We actually use integers, but these are internally converted to doubles, which define colors. And you can see previously the color, frag color, is a vector of 4 elements. These are vector of 3. This is just a simplification. Actually, the color is vector of 4. This is just for internal computation. And let's see the main. So first thing we do is actually we take a position where we are. And we try to normalize it. So, okay, did we say resolution? Yes, resolution. Let's go back. There is also a uniform resolution. Uniform means is an input variable that's uniform in all executions of a shader. So it can basically be copied over efficiently through memory to be available to all the shaders. There can be other, let's say, non-constant input variables, but we are not going to cover them. And most of the functions operating on the image like to take a normalized version of image starts at 0.0 position and expands to 1.0. So we need to take a resolution that we are given, take the coordinate in, let's say, integers that we are given and divide them. These are both vectors of 2 elements. We can divide them easily, and that's just scalar division. Then we take some color, which is full of zeros, and a %, which is also a vector of 3 values, which is a position, actually. And we get some color that's a mix of red, green, and blue. I'm going to show later what this does, but this is for you to just understand how a basic shader looks like. And then we output to a frag color the vector of 4 values with some 4th parameter of, I think it's alpha channel. And once we are done, this is what we need, and the Flutter will pick up, actually not really Flutter, but the screen will pick up the frag color and display it on the screen. So that's a very basic shader, and I'll show later what it does. But let's talk about how to use it in Flutter. So we cannot just say, okay, this is a shader, and I don't know, put it as a code block in our code and say, please execute. First, we need to prepare. So just as we have assets in pub/spec YAML, we also can declare shaders in a Flutter section. And basically, all these programs, all this code needs to be in some files that are accessible to the bundler. They are usually named .frag, sometimes .glsl, depending on a convention, but it doesn't really matter. This is just a path. The other thing that we would like to have is a dependency on Flutter shaders, which is not strictly necessary, but it makes interacting with shaders easier. And then we can write something. So our step of preparation is actually loading the shader. And to use this, we use the Flutter Shaders library. To do this, we use the Flutter Shaders library, and we call the static function Flutter program.fromAsset, put a path there, and await until it actually loads. The program then has a property fragment shader, we can call it, and we get a fragment shader object. Now, with Ski and with most of the things so far, let's say pre-Dart 3.0, pre-Flutter 3.10, this step also compiles the shaders. So the first time we try to load a shader, it actually gets compiled internally to a representation that can be later used on GPU directly. And if you ever encountered a problem with, like, the first frame of some animation or some nice effect is very slow and laggy, then this might be the cause of a problem. Right now with Impeller, this changes. Everything that we load actually is precompiled, so there's no compilation step. But if you use this, remember, this is actually quite intensive. There are some ways to avoid this compilation problem, but none of them are really good, well, if you don't use Impeller. Okay, so we have that program, a fragment shader. There are a couple of methods we can select to actually make use of this fragment shader. The first of this is a custom painter. Who implemented a custom painter before? Great. More people, that's what I expected. I hope that actually some people did this, because this is quite basic knowledge, no? Anyways, custom painter allows us to take more direct control of our screen, and the core class of the custom painter is actually the paint. You can see here. Paint allows us to do lots of nice 2D operations, like draw a circle, draw a line, maybe a curve, maybe a rounded rectangle here and there. But it also can take a shader. One thing to note is that if you specify a shader, which is a shader program, this is not compatible with all the other paint properties, so you need to take a look at the documentation to see what you cannot use if you use shader. But yeah, we'll use a paint class to actually draw our shader. And you remember how we put a resolution there as a uniform that we want to give to our program? So shader needs to get this argument somehow, and we call basically shader.setFloat. And the first parameter to set float is a position of that variable. And now, remember we had vectors of values there. So each vector, and for example, the resolution here is vector of 2 values, will basically be indexed from 0, and the next value will be indexed from, like, continuously starting from 0. So whenever we declare values, we need kind of to remember which order are they declared in, so that we can put values with the direct index in the proper place. So here we set this resolution of our image. And then we use the paint to actually draw on a canvas. Canvas is given as a parameter to paint above. And we use it to draw a rectangle with that paint. Now a second thing, that was understandable for people who didn't use custom painter, maybe. And for people who used custom painter, I hoped it was understandable. But custom painter isn't the only thing. So custom painter allows us to draw a shader. That's great, but it's not all we want to do. Sometimes we want to put a shader on top of the other image. And we can do that with the shader mask widget. And the shader mask actually does a very similar thing. I'm not going to show specifically what it does, I mean, line by line, but it also gets some kind of a shader set some float, returns a shader from shader callback. We do blend mode, and we put a child. A child would be an image actually, or widget we are going to paint our shader on top of. And the blend mode you could actually know from other widgets that combine two widgets or interleave two images. The blend mode modulate is actually the nicest looking, but there are plenty of things you can do with blend mode. You can say the second image is kind of a mask of brightness. It can only darken the image. You can actually discard one of the images. It's basically how to combine two images, one of which is going to be a shader with shader mask, and the other is going to be your custom widget. And one other way, and most complicated but also most powerful, is to go back to Custom Painter and use an image sampler. So with these previous two examples, we actually didn't care, our shader didn't care about the image that it paints underneath. So here we just did a Custom Painter that draws a shader. Here we interleaved a shader that doesn't know about the image with the image using shader mask. And here actually we give the shader access to our image, to the original rasterization of the widget, to make it actually process data. You can imagine, like, without this it would be really dull to do anything because we wouldn't know what the pixel is when we try to draw it. And I'll show you how we can actually use this effect. Use this to produce a nicer effect in a real shader. And here we use very similar thing. Set float and set image sampler, I think, are the only two setters on a shader that set variables, and both of them have their own indexing. So set image sampler also starts with 0 for every image that we try to use. One caveat here: don't try to access images a lot in shaders. Shaders are great for parallel processing, but they don't have as great cache access as CPU does, or calls on a CPU do. So getting some pixel from an image is a little bit difficult or a little bit expensive for a shader, and so you should avoid doing it a lot in a single shader execution. But that's a caveat if you want to write shaders. Oh yeah, and if we do a sampler, we need to declare a sampler like this. We just say, yes, it's a uniform. Again, that means it's the same for every shader execution. And sampler to D, that's a type. Yeah, that was a lie. The other things were floating point numbers. There's also sampler to D, but sampler to D is basically just a collection of a huge matrix of pixels. And to access this matrix of pixels, we use the texture function, which is built in GLSL, to get, in some kind of position / resolution, so normalized one, color, which is a vector of 4 elements. All right, that was it for dry examples. And let me try to run some shader now. Okay, let's start with the first thing. So what I presented in the beginning, that the full code of a shader is going to be shortly on the screen. And it's really nothing exciting. It's actually taken from Flutter's examples of shaders that I think maybe they use for testing. But yeah, there's a very small example. In Flutter code, it's actually 3 different shades of blue that don't look like anything, so I put red, green, and blue. But you can basically see we have 3 colors that mix in between themselves throughout the image on a diagonal. That's it. We can maybe resize this, or maybe. What did we do? And you can see shader actually does all the paint inside of this box, and it does it quite efficiently when we scale. Now that's not going to be exciting. So let's do something different. This is an example with the shader mask widget. So we get two images and we interleave it in the shader. Now, you can see shaders also can produce nice effects, like some moving effects, because we can actually pass any variable to a shader execution, and this variable can also be a time. So if you pass like current seconds from epoch, you might do something with it, like position these nice little clouds on an image. And that's what shader mask does in an example like with this blend mode modulate. The shader itself just paints white on, I think, no, semi-transparent white or black pixels in some shade. So it itself doesn't look like much, but I mean, it doesn't look like much. It's really nice. And this is actually a quite simple thing. If you take a look at the code, you might find like code for shaders like this everywhere. It's just few operations, few mathematical operations combined together that can make this kind of effects. It's not like a lot of modeling that you need to spend time on. Although, yeah, any experience with computer graphics, I guess, would be appreciated, so you would know how to combine actually. So that's the second example. And I'll show you another one, which uses, of course, the third method to take an image and sample it. It's unfortunately not going to be a very visible change, because what we did with the sampled image is we blur it a little bit. On top of it, we also add this nice effect of basically a light on top of the cursor. As you can see, this is a very efficient thing. Like, imagine this shader actually runs every frame for all the pixels on my screen, which is not like a small mobile. It's written, it's executed in profile mode, so it's not a debug mode. It could be slow in debug mode, but I can also show you the performance of this nicer shader. And you can see on top we have the performance or profiler performance view, where when you see a bars, it's how long did it take to render a frame. And I can do a lot of things. It doesn't take anything, really, to render this frame wherever I put it. Like, the bars are very low. So the line there is like 16 milliseconds, which is, let's say, a standard below which you need to fit if you want 60 hertz screen, or 60 hertz image. So that's it for the examples. Now, two links that you can follow to actually learn a bit more about shaders. One is the Book of Shaders, which is nice introductory series of articles, a web page on shaders. It's approaching the shaders from a little bit, of course, little bit different route than we did. And yeah, basically it's also technology agnostic. It's not really telling you, how to use shaders in Flutter or any other language. It's more about shaders themselves. But it's really nice if you want to learn something about shaders and how to write them and what to do with them. And the other URL is going to go to the simple shader sample that's in a Flutter repo. You can take a look if you want to have a concrete example how to use a shader in your application. Okay, that's it. Thank you for listening.
All right, thank you, Krzysztof, for your speaking. Are there any questions for Krzysztof?
There is one from the audience.
All right.
Thank you, Krzysztof, for such a good presentation. I'm gonna ask you a question about the accessibility to store those shaders. Is there any other way than the assets?
Excuse me, again?
Yeah, I'm gonna repeat the question. Is there any other way to store those shaders than just under the assets?
No. I mean,
Alright.
you don't need to have it assets, but you need to load them together as a bundle in a system. Now, I was talking a little bit about Impeller. Impeller actually preloads, pre-computes these assets into intermediary form. Actually, it has several compilation runs, but yeah, normally you need to load them somewhere, or tell Flutter that it needs to compile them from somewhere. Yeah, you cannot hot load them. It would be quite difficult.
Okay, thank you.
All right, just a quick reminder, you can ask the questions online as well, and we'll just read them here. Any other questions maybe from the audience? We'll give a minute for the online audience if they have a slight delay. If not, then thank you for the insightful presentation.
Thank you.
And we will be, also a quick reminder about the rewards. Our participants are able to give them out for the active participants, just a reminder. And also we'll have a quick break, probably 10 to 15 minutes, and we'll be back with the last presentation. So 10 to 15 minutes. All right, we'll wait a minute for the people outside, or probably they will join us in a second. So we're live? Okay, perfect. So the last presenter came to us from London, straight from the quarters of JP Morgan, and a special guest, Teresa Wu, that will be sharing some insights on Flutter on desktop, so end-to-end form from build to distribution. She started her career as a business analyst, and then she got the opportunity to work as a software engineer while studying computer science at Birkbeck, University of London, and then slowly developed her career in IT. Teresa is a public speaker, Google developer expert, a mentor, a software engineer who's passionate about front-end development and cloud technology. So thank you for joining, and the stage is yours.
Thank you. Thank you. I'm really happy to come here, and I had a nice tour of myself walking the city yesterday, and it was a really nice place. And thanks for having me here. My name is Teresa, and as you heard about my brief introduction already, so I work for JP Morgan as a software engineer. And I'll be talking about Flutter, but on desktop. So how many of you here are desktop engineer or used or built a desktop before? Okay. So the reason I'm asking is to understand my audience, and also I've given this talk before, and I got questions asking me very specific about desktop. But I have to say I'm not a desktop engineer myself. So be easy on your questions for me later on, but I'll talk about Flutter. Maybe you are thinking, right, I know Flutter, I use Flutter for mobile, and I maybe heard about the Flutter for web. And really, hold on, now I'm using Flutter for desktop already, right? So I will walk you through the journey of building a Flutter app, like a very simple one, on desktop, and you should be able to understand, like have a very brief knowledge about building it for desktop if you haven't tried it yourself already. So we will quickly begin. So actually, before we start, right, the fundamental difference for myself, right, trying Flutter for desktop is for using Flutter for mobile and for web, I can just use my computer. Doesn't matter if it's Linux, Windows, or macOS, right? I can use one computer for everything I need. But going to desktop is quite different, and you will see why. And I'll walk you through how we set up Flutter on each of the OS, and talk about how we distribute it as well in the end. So a bit brief of the journey of Flutter for desktop. So what we will cover today, as I mentioned, we will talk about the setup, some case study of why we need the desktop application, and talk about some very specific Flutter package for desktop, and how we release the application on each platform. Great. So as you can see on top is a background of Flutter, which I'm not going to dive deep in because you probably heard this a million times already. But for desktop, it was first mentioned in 2019. And slowly through the year, between 2020 and 2021, you have a support for Windows. And last year, we have the support for Windows goes live, and then come with Mac OS and Linux. And this year in Flutter Forward in Kenya, desktop was actually officially mentioned as one of the major branch for Flutter family. So now we have Flutter covered for most of all the platforms that we can think of, right? Desktop, mobile, Windows, for web, and for car, for wearables. So as many as you can think of, right? Also including embedded as well. A bit of comparison, because as you know of today, if you're thinking of cross-platform tools, right? Maybe Kotlin multi-platform is another very popular framework, but unfortunately it doesn't cover UI at the moment. So we have either Flutter or React Native, right? Which one should we choose? So if you are thinking of building a mobile application, you can use any of it, right? And it all depends on your situation, because every project, every team is different. As when you come to web and Windows, Mac OS, they differ from each other. So Flutter now fully supports all those platforms, whereas React Native, it supports web by its community. It supports Windows and Mac OS by third party of, for example, Windows on its own. It hasn't supported Linux just yet. So just some data comparison. And why do we need desktop application? If you think of anything that isn't included in my slides, feel free to raise up your hand and I'd like to hear your thoughts. So similar as we built for mobile application, for desktop, it's native, right? So you can access your application offline. You can save data in a more secure way, and it has better performance. And again, it's native. So you have this familiar UI and the familiar things as if you are using a desktop application for your own OS. So as again for web app, you can self-updating it, right, without publishing or releasing it from App Store. And it's accessible anywhere. You don't have to install it, and it's probably lighter. And some of the very popular desktop application again, right? I think most of the time when we're on the mobile, we're using mobile application. And again, most of the time when we use our computer, we're on the browser, most of the time. But there are lots of applications we use on desktop that we probably don't even think of, but we do rely on them daily. Like engineer, we use IDE. We have editors. We use Zoom, probably, or Team. And the Spotify, right? Who doesn't listen to music when you code? And email app, Slack, right? All those apps, actually, we probably have all of them on our computer. So it's a good actual use case to build desktop applications. And now we have the ability to use Flutter for desktop application development. And in the next few slides, you will see lots of data, information, but don't worry, I'm not going to read them line by line, but walk you through how we set up Flutter on each of the OS. But before you actually grab your computer and starting to install everything, right? If you have installed the Flutter already for other platform, do a quick run of Flutter Doctor, right, to see what you have and what you are missing. So you have lots of information already and knowing what you need for your current OS system. So if you have the SDK installed, make sure you meet the minimum requirements for desktop. And what do I mean for that? Again, let's start with macOS. So the minimum requirement here is to have like a 2.8 gigabyte space. If you don't have 2.8 gigabyte, you probably need a new computer. And have the SDK installed. And on the official website, you have the list of all these latest released channels and the versions, right? This might be old already, but you definitely see the new ones from the website. And if you are a Mac user and having Flutter running on your computer for desktop, is probably just within 5-10 minutes setup, for sure. You just need to add to your path if you are the first time using it. But if you have already Flutter, right, you can just skip lots of those steps. And again, you probably have Xcode and the dependency installed already. And if you run Flutter Doctor and see everything as green tick, you can actually quickly create your own app and run the last command to run the macOS, and you should see the Flutter app running on your computer straight away with no any issues, right? It's quite straightforward. So as myself, I'm a Mac user, so I found that this process quite straightforward. But if you use other OS system, if you look at your project, right, you might see some additional folders, something that you don't see before. So you have this macOS folders, has few subdirectories inside it. So Flutter, as usual, contains some of the files. You probably should ignore it, or generated files. And the runner package has platform-specific code. Then followed by your source code and dependencies between your projects, similar as your usual packages in other platforms. And now, if we move on to Linux. So if you used Linux before or familiar with the system, you might again find this process quite straightforward. Here are some minimum requirements, and as usual, you'll find the latest stable version for Flutter for desktop. And if you are building a commercial project, I would recommend always go for the stable one. But if you're trying it out, go for the dev version, just be more adventure. And okay, because myself is a Mac user, so when I install Flutter on Linux, I actually spend more time on it. So run Flutter, have Flutter installed, run Flutter Doctor. I see lots of red cross, right? And yes, for Linux, you have to install lots of dependencies and the packages. And, oh, right, sorry. So here are the list of them, but I will explain a bit what they are. Once you install those things and you run the command again, you should have your first Flutter desktop application running on Linux. But let's have a little bit of deep dive in of the file system of Linux, right? So those are the, as for now, the recommended and required packages you need to have to support the Flutter. So you have a few of them for the tooling infrastructure for C family, cross-platform tool, UI element, and build system. And again, right, compression and decompression. So those are the required packages you have to install for Flutter. And again, our last one. Sorry, this might be lots of data, but if you actually try it once, you will have this set up forever. So again, for Windows, similar story. We download the SDK, we check the latest version, and we install the SDK. But there's a little bit extra requirement for Windows. You will see why here. So apart from install the SDK of Flutter, and one of the requirements for Windows, apart from having Android Studio IDE, you have to install Visual Studio, right? It's not a VS Code. Visual Studio, and you need to enable one of the tick, as you can see in the picture here. Maybe it's not very clear. So one of the option you have to select is desktop development for C++. That's additional requirement you need for Windows. And for Linux, all you need is just Android Studio. And again, very simple. Once you have everything installed, run Flutter Doctor, everything's green. You create your project, and you can run your very first Windows application with Flutter. So those are for you to set up as a new project if you never had a project in Flutter before. But if you do, we will actually, before we jump into the next slides, testing, right? So you might be wondering, how do I do testing in Flutter? So for myself, because I did like a sample, very simple project, so I don't find anything that is quite special that you need to do for testing in desktop. So you do as what you do before. For unit test, you install the same library, run the test as you do. This is one of the beauty of using cross-platform technology like Flutter. So you don't have to do anything more of platform specific. So everything is underneath one hood, underneath one language, with one test. Right, so this is what I was mentioning before, is what if I have a project already in Flutter and I don't need to create a new project? So this is taken care of by the Flutter team. They thought about it already. So you probably have a web or mobile app in Flutter. If that's the case, after you set up all the environment, you don't have to actually create a new project. And it's very simple. You can just add desktop support to your existing project by running this command. So after you run this command, you can either enable all of them or one of them and have desktop, and you should see those Flutter project subdirectories created for you in your project. Okay, so now we have our environment set up on those 3 platforms. Now we're going to go into building it. And for a desktop application, I'm sure you have different requirements. But again, similar as you do for web and for mobile, you can use this bridge to go into the native language, doing the native framework you need. But if you are actually coding in Flutter environment, do as usual, as you would do for any other of your project in Flutter. But here are some specific cases you might need to think about a bit more when you build a desktop application. So first is the keyboard and navigation. So as for desktop, right, for mobile, right, we can tap, click, and use gestures, swipe. For web, we can click, maybe tap as well, depends on what device you use. But for desktop, we have the screen, and we have the keyboard. So when you design a desktop application, think about how you support the keyboard, how you do navigation, as for one system. Here are some of the language and framework that you have already supported in Flutter. You have the physical keyboard key. What you can do is you can actually specify the events for a very specific key you want, like key A, key C, or key N, right? And you can add your own action for those keys in Flutter. Or you can create shortcuts, which means you can create a combination of different keys into one and create events you want for those shortcuts. Another thing that you might need to think about is data, right? How do we store data? How is data supported on desktop application? So if without having a framework like a cross-platform like a Flutter, right, you have to think about those different data storage locations for each of the OS. So for Linux, right, the directory for data store is in one place, which is very different from OS and from Windows. But this is being taken care of by a Flutter framework already. What does it mean is, again, for Windows and for OS, Mac OS, and for Linux, most of the very popular and that's something that you use daily, right, for in Flutter are actually supported, like shared preferences and secure storage. So for secure storage, right, you just have to create different options, like for Windows, for Mac OS, and for Linux. So then you have access to the secure storage in each of the device in a more secure way. And something in addition, right? So again, each platform has its own specific requirements and difference in how you store data. So some of the things are kind of limited at the moment for Flutter on desktop for now. So for example, for Windows, right? Read all and delete all functions at the moment is not supported. And for Mac OS, you need to add keychain share to the runner, right? So those are kind of difference for now, but they will be developed in the future by the team. And again, a bit of comparison again, of if you are thinking of using the file system on each of the OS, and you can store either shared preferences and secure storage, or even store large data locally. Here are all the supported directories you have in Flutter, but not everything are supported on each platform. So when you add your code, your functions to those file system, if you see errors in the box, right, it might not be your own coding bugs, right? It might be because it's not supported yet on this OS system. So think about what you need and check the latest supported platform and the tools on the website before you start using it. Otherwise, you might run into a dead end. And last thing, I think, is you might think of on the desktop is a supportive, responsive design. And again, this is something that you do probably many, many times already in Flutter, and you do exactly the same thing in desktop. That's the beauty of using Flutter. And in a Flutter Forward in Kenya, the team actually announced multiple windows. What does it mean? It's not multiple windows for Windows OS, right? It's multiple windows in Flutter that you can actually duplicate your current window into multiple windows, and they actually sync with each other. So if you add some data or have some user interaction in one of the window, it link to a different window as well, if you code it in that way. But at the moment, this feature is still a prototype, so we don't have access to it, even as a dev tool. And the team is working on this feature at the moment, and I'm still waiting for their future announcement of when they can be available for us to try out. It seems pretty cool. And the Google team did a very interesting but a bit short video. And on this feature, you can find on YouTube as well. So if you wanted to see, and I think in multiple window is not just for desktop. When it's available, you might find it in other platform as well. So after trying out Flutter for desktop myself, here are some of my thoughts. Happy to share and have to hear from you as well. So we don't have, so when I built Windows and Linux from as a Mac user, I do find that the testing tool and emulator is a bit of an issue. That means if I'm building something for my side project, or I'm a startup company, to use a Flutter for desktop, I have to have at least 3 machines, or have at least one of them to be virtual. So maybe we can have some pre-made Flutter VM in the GCP family. That would be nice, or in the marketplace, and maybe have some more documentations, right? And if I'm building Flutter for desktop, one of the things I'll be really happy to know, to have some guidance, is universal design system. How do I use design system in a universal way for all of my OS, right? Because each of those platforms have this own special UI element. Right, so here are some of my thoughts. I'm happy to hear what you think that can be nice add-on to Flutter, especially for those who are expert in desktop applications. Right, so last part of my talk today is release. So this also is my part of my of something I'm really quite enjoying talk about and work with: pipeline, CI/CD, and distribution, automation as well. So you can actually distribute your application to each of the platform manually, and here are how to publish it manually on Mac OS. Right, you first build your application with either build flavor or release, for example, and have yourself register on the App Store, have your bundle ID, right? Have like your developer account. And once you have your app ready, you can have the code assigned as well, right, to make your app unique. And you should be able to publish it on the App Store. For Linux, it's similar-ish, but instead of having a developer account on App Store, you have your account in a different place, right? Install the Snapcraft and install multipass, right? Build the app and publish it through Snap, right? Very similar. And for Windows, you have 2 options, right? So it's similar to Android in a way that you can either publish it everywhere, anywhere, or you can have this package installed, and you can publish it from the Microsoft Store. That means Microsoft will manage your application life cycle for you, same as for your Android and iOS application. And they actually manage the deployment for you as well. But again, that means you can only deploy through Windows Store, but it's quite secure in a way. So if you think distribute manually is better work, how do I automate it, right? There's definitely ways to automate the process as for now. So those are probably, as for now, those are the companies and the tools I found support desktop for Flutter. There might be more, and sorry if I didn't mention them. And I will give a very quick overview of how to use one of them. The reason I choose Bitrise is because I used Bitrise before in my other project, and I'm quite familiar with its UI. So, but I'm sure if you use any of the framework and the tools from any of the tools here, the process should be similar-ish. So if you are thinking of automate the process, right, you can have your account with Bitrise, for example, or CodeMagic, and having your repository set up, so you have these steps here. And for production application, you might need extra steps to make your app a bit more secure. But those are probably minimum requirement for what you need. Have your Git set up, right? Have Flutter installed, have the desktop configuration, and the reason I'm saying you can automate this is like all these steps are pre-made for you. You can use from the tool itself. You don't have to create everything yourself, and you can reuse them every time. And set up a timer as well, probably release every other week. And once you have a tool for you, set up the tool, right? You then probably have the automate release process already. So in the end, if you are thinking of Flutter for desktop or not, right? So there are different cases, right? Because when I talk about Flutter, I heard the question a lot is, should I use Flutter or not for my project? As according to my dear friend Majid, he will tell you it depends. So why, right? Different situations. What if I have existing mobile application and I want to extend it to desktop? What if I have existing desktop application and I want to rewrite it and have it support other platforms? What if I have a desktop application and I don't want to distribute via any other platforms? I only want to build a desktop application. So what should I use, right? Those are different scenarios. As for your project, again, I don't have the right answer for you. It really depends, case by case. But think about your project first. Think about the resource you have in your company, the resource you have locally in your city, right? And think about your pipeline. I mean, the pipeline to build, to publish. How long do you have? Are you a startup company? Are you established? Are you, do you have like, what kind of resource do you have? So those are all the questions you should put on the table before you decide which framework is there for you. So that will be my talk for today. Thank you for having me.
Thank you, and thank you, and of course we'll have the round of questions. So any questions from the audience? Maybe Kasia will pass the microphone, if any. And of course, we're also waiting for the viewers and online audience to ask, and feel free to shoot out the questions. There's one from Szymon. Come on. Oh yeah, thanks for passing.
Yeah, so about desktop, Flutter on desktop, there was a lot of controversy that it's not production ready. So what do you think about it? Is it a production ready framework at this stage?
Yeah, that's my slides here. It depends. So I feel when I try Flutter on desktop, I feel I'm trying Flutter again for mobile. in 2017. So I definitely would recommend to try it, but should you use for your production application, depends on how big, how many features you have for your desktop application. If it's like a one-screen app or if it's a game app, right? It depends on the situation, but I feel like I'm like 5 years ago trying Flutter for mobile.
Okie dokie. Now, any other?
And you get a little present from the organizer if you ask questions.
Yeah, and by the way, obviously you will still have some time to ask those questions at the networking afterwards, but maybe some online. Oh, by the way, I see the one of the viewers asked the online question. So, are there any other limitations that I should know before I choose Flutter for a multi-platform desktop app? Question from Aithul AK. Thanks for that.
Again, it depends. It depends on really your project. As for today, if I compare Flutter for mobile and to desktop, the supported features and the supported functions definitely a lot more richer on mobile. But I see the progress of Flutter through those years. As for today, right? When Flutter first announced for web, it wasn't adopted very widely, but now you can use WebAssembly for web. So now I see Flutter for desktop as mentioned in the Google I/O, and the tools are definitely coming in our table. So. Depends on your project, but it's definitely worth to have a try.
Thank you. Well, since there is a slight delay, we'll just wait a minute for the online viewers and the audience. Maybe in the meantime, if not, then there is one. Can you pass just the mic? Thanks.
You can even ask me how the weather is in London. You get it back.
Hi, you mentioned the GCP virtual machine on the web to test the desktop application. Is the most convenient way to test it on various platforms?
Right.
Or what is the most convenient for you?
Okay, so very good question. So as I was saying is, if I build a mobile application or web using Flutter, I can have one computer. It can be Linux or Mac OS, right? It covers for me for web, any browser, and mobile for iOS and Android, or even probably for wearable as well. But for desktop, you need to have that specific OS. So that means you either have this machine yourself, have a Windows machine, basic Linux machine, or you have to have the virtual machine. So you have to have the actual OS that supported for the platform you want to run. There's no emulator you can find today for desktop. So that's for the question later on, that's one of the limitations. It's very hard to test and to see your app running on the system. So unless you have 3 machines.
Okay, thank you.
Okay, I see no hands or. Okay, so Kasia will be summarizing soon, but in the meantime, thank you very much. And
okay, guys, so we want to thank you for joining us today. Join us for networking on the rooftop pub. Presentations will be available in the link on our Facebook page and on the YouTube GDG. So thank you very much and enjoy the evening.